Welcome to Lesson 1 from our Motion and Forces unit. For this lesson, you should have your note sheet out in front of you, and you should be paying attention for our hidden talking points. I believe there are 2 of them throughout the video. Before talking in depth about motion and forces and all kinds of other things, we need to start by talking about motion and position. So we're starting just with the letter I on your worksheet. Letter A, you don't need to see things move to know that they have moved. If you look at this picture here, you know that the mail truck has moved because its position relative to the mailbox changed. And what I mean is that here it's close to the mailbox and here it's far away from that same mailbox, so you know that it moved. Continuing, motion occurs when objects change their position. All right, now moving on to letter B. Letter B talks about reference points. And a reference point is something that lets you know that something has changed position, such as the mailbox in this picture. So the mailbox is basically letting us know that the mail truck has changed positions. Moving on to letter C. Letter C says that when we describe motion, it's important for us to measure distance. Distance, so write distance again, tells us how far an object has moved. So in this picture we could see and we could measure out how far the mailbox has actually moved from the one mailbox to the next, and that would let us know the distance that it has traveled. For us, long distances are going to be measured in kilometers. That's kilometers here. While short distances are measured in centimeters. We'll get this out of the way. There you go. So kilometers and centimeters. Next we're going to move on to talk about speed. This is a picture of Usain Bolt. He's the fastest guy in the world. That's why we have this picture on here. Speed, letter A, says to describe how fast something is moving, we use a measurement called speed. To calculate this, we need to know how far an object, and when I say object, it could be a person, it could be a thing, has moved in a given amount of time. We have an equation that lets us calculate how much speed something has, and we're going to work more with this when we do our lab next week. But to calculate speed, we're going to need to use this equation here. So you can write this whole thing in your sheet, and you're going to have speed equals distance over time. So you need to write this first. And then the variables are S equals D over T. So next, letter C says, suppose you ran 2 kilometers in 10 minutes and you ran 3 kilometers in 20 minutes. Which one did you run of faster speed? And so what we need to do is we need to use this calculation. So if we ran 2 kilometers in 10 minutes, we'd write S equals our distance, that's 2 kilometers, divided by 10 minutes. So for this one, if we do that, we went basically 0.2 kilometers every minute. And for the next one, our speed equals 3 kilometers in 20 minutes. And that equals 0.16 kilometers per minute. So we went faster when we ran 2 kilometers in 10 minutes. That one right there. Okay, so that's what you would write under letter C. Now we're going to shrink these, and we are going to move on to letter D. It says when you are traveling in a car at the same speed always, this is called constant speed. So we have a picture of a car here, and we're moving at the same speed always, so we're at a constant speed. Most of the time when you are traveling, you are not moving at constant speed. So you can write constant speed again. When you are on a bike, you slow down and stop, or you speed up. This is called changing speed. So if we look at this picture, you can see that sometimes our speed is really low, like down here, and sometimes we're moving really fast up here. So this is like we were biking to our friend's house, and sometimes we're stopping at stop signs. Maybe here we stopped at a stop sign, and maybe here we're riding back down a hill or something. Moving on, it says many times when we find speed, we are actually talking about our average speed. So the next blank is average speed. So in the bike example, if you took 0.5 hours to get to your friend's house and your friend lives 5 kilometers away, your average speed, so write average speed again, was 10 kilometers per hour. The very last one that you have on here is letter E, and letter E says that instantaneous speed is what your car is going at one instant when you look at the speedometer. Number 3A, a distance versus time graph makes it possible to show the motion of an object. Look at the red and the blue lines in the graph. In 10 minutes, the red line went 800 meters. So if you look at 10 minutes here, it went 800 meters in 10 minutes. So you should write 800 meters there. At the same time, the blue line went 600 meters. So if we look at the blue line at 10 minutes, it also went 600 meters. Therefore, if you look at these lines, the blue line is not as steep. This steepness of a line is called slope. And it lets us know the speed at which something is traveling. Letter B. To plot this kind of graph, we use the x-axis to plot time and the y-axis to plot distance. Sorry, I made a mistake here. So we use the y-axis to plot distance. And letter C, once we connect the points, we can see who traveled faster and who traveled further. The last part we're going to talk about velocity, and it says letter A, suppose you turn on the radio and hear about a tornado in your area. If the weatherman only tells you the speed, you have no idea if you are safe. He must tell you a speed and direction. Letter B says velocity tells us the speed of an object and the direction of its motion. For our one and only talking point now, at the very end, I want you to write what are two other examples where knowing the velocity of something, so knowing the direction something is moving, is very important. And that's going to conclude lesson 1 from motion.